Our second example, example 2 from page 12, asks us to determine the number of terms in a sequence. So the example says, the muskox and the caribou of northern Canada are hoofed mammals that survived the Pleistocene era, which ended 10,000 years ago. In 1955, the Banks Island muskox population was approximately 9,250 animals. Suppose that in subsequent years, the growth of the muskox population generated an arithmetic sequence in which the number of muskox increased by approximately 1,650 each year. How many years would it take for the population to reach 100,000? Okay, so when they tell us it's an arithmetic sequence, they mean that every year a certain number of animals is added to the population. So, you know, it's not growing exponentially like you would see in, say, bacteria. It's just there are 9,250 in the first year. Okay, between the first and the second year, they're adding 1,650. So when you add that together, you're going to get 10,900. That would be the population in the second year. Okay, to get to the population for the third year, we'd want to add 1,650 again. Okay, so we're getting to 12,550. Okay. In the fourth year, to find the population in the fourth year, we're going to add that number again. That's going to give us 14,200. And I don't know how many terms we would have in between here. Okay, but what we're looking for now is the last term. That would be 100,000. Okay, that's going to be the term. Not necessarily the last term because it obviously would continue to grow, but that would be our nth term. Okay, and the reason that we call that the nth term is because we don't know what number goes here. Okay, so this is T1. This is T2, this is T3, this is T4, and this is Tn, and n is our unknown. Okay, so we know, and remember we have an arithmetic sequence, and so it's got certain characteristics. Okay, the first term, 9,250. The second, or the common difference, that's what we add to each term to get the next one. So we know that we're always adding 1,650. Okay. And we know what the nth term is. It's 100,000. What we don't know is what is that n value that goes there. So this is really, what is this value? That's what we're going to figure out. Okay, so n is our unknown. Okay, we know that we can use our arithmetic sequence term formula. So that'd be T sub n is equal to T sub 1 plus n minus 1 times d, okay, because we're going to add the common difference one less time than the number of terms. So we substitute in the values that we know. Okay, we know that this is going to be 100,000. Okay. We know that this value is 9,250. We don't know n, okay, but we do know that d is 1,650. Before we solve for the n, I guess what we can do is we can distribute the 1,650, just like that. Let's extend the page here a little. All right, these two are like terms now, right? 9,250 minus 1,650. So you can group them together by subtracting. That gives you 7,600. So we'll just write the n term and then 7,600, which is what you get when you subtract this from this. Okay. Still working our way toward the n. We'll subtract 7,600 from both sides. This side becomes 92,400. This side 1,650. And then to get the n by itself, we need to divide by 1,650. And so our n value is going to be 56. You can use your calculator for these calculations. It's just a matter of whether or not you're setting it up properly. And then go ahead and use your calculator. 56 is our number. Now, the reason why we always want to write a sentence at the end of these problems is because you need to make sure that you know what that n means. Okay? And what that n is, that's the number of years that it's going to take for the population to reach 100,000. Okay? So this is going to happen in the 56th year. Okay? This is the first year here, second year, third year, fourth year, and this is going to be the 56th year. Okay, it's actually T sub 56, because now we figured out what that n is. So in order to demonstrate that we know what the question is asked and what we figured out, we write it as a sentence. Okay, it will take 56 years for the population to reach 100,000. 100,000 muskox. And that's it.